Let's build a cooling system. In every cooling system, every typical cooling system, there's a million ways to cool people. You can cool people by blowing water on them. You know, it's called evaporative cooling. Ever been to a football game, preseason game in the summertime? And on the sidelines, you see the players sit in front of these fans, and the fans have water. The fan is turning, big propeller fan is turning, and they're spraying water in front of the fan, and that water's blowing on the players. Because as that water evaporates, you got the wind chill effect working again, it makes them feel cooler. And it helps take the heat out of their body, because anything that boils, vaporizes, takes heat away with it as it does it. All right? So, we got this compressor. We're going to build a refrigeration system. We're going to take the refrigerant out of this compressor, and it's a compressor. What it does is compress refrigerant. It makes it very hot. The refrigerant actually starts out in its path very hot. And we're going to have a coil, a big condenser coil. And what this is just a serpentine coil. It enters here and goes all the way around and comes down here. These are return bends and starts all the way back. And it does this over and over again for the size of the coil. How big is this coil? How big is the system? Because it's got to match this compressor's capacity. So that's the condenser coil. Then we're going to add a condenser fan. We're going to put that on the top of this particular one. And it can be on the side. It can be a draw-through, a blow-through. It doesn't matter. But basically with this design, what we're going to do is pull air in from the outside, 95-degree air in from the outside, over this coil, and we're going to discharge the air straight up in this particular case. Now we could do the opposite. We could blow the air down in here and push it through the sides of the coil. But that's not as efficient as pulling it through and blowing it up in this particular design. Just suffice it to say the fan is going to take this heat. Now this line coming out of the compressor on a hot summer day could be close to 200 degrees. It very often is 180 or above. Okay, very hot. And what's going to happen here in the condenser, we're going to take this hot gas. This fan is going to blow 95-degree air over 200-degree gas. And guess what? It's going to cause that gas to condense because it's going to take heat away. 95-degree air can take a lot of heat off of a 200-degree refrigerant. And it's going to cause the refrigerant in there to condense. And hence the name condenser. That's the condenser coil. When we're all done, this whole thing is called a condensing unit. And a lot of people get messed up with that. Oh, I need a new compressor. Okay, you show up in the job and this thing has been, a tree hit this thing. And the whole thing is destroyed, the whole condensing unit. And you say to the guy, I thought you wanted a new compressor. So, no, I need a new compressor. It's not a compressor, it's a condensing unit. A major part of the condensing unit, the whole system, is a compressor. Now, we're going to take this, which now is a hot liquid, and we're going to take this hot liquid out here. It started out as a gas. We took heat off of it. It condensed to a vapor. Think of it in terms, the refrigerant in here, which is a wonderful product. Think of it as as steam. This was a little steam boiler that compressed steam and sent it out into this coil, and we blew air over the steam, and what happened? It condensed back to water again. But it's still hot water because it was just hot steam a minute ago. So now we're going to take this hot fluid, we're going to run it up what they call a liquid line, and at some point we're going to get to this thing inside, because this whole thing is outside. We're going to get to this thing inside, which in this case I'm showing you what we call an A-coil evaporator, an evaporator that sits on top of some kind of an air handler, either a blower, a furnace that could sit right on top of the furnace. The heat exchanger would be down here, the blower would be here, and we'll use the furnace blower to blow air over this coil. Because when this hot liquid enters this coil, there is an expansion device, and this is a serpentine coil too. You see all the return bend and passes here. Just like this, except it's not one pass, it's layered. There's about 4 passes in each side. And it starts out here and it goes back and forth and back and forth and it ends up here, it goes back and forth and back and forth and then out the other way. So as the hot liquid refrigerant comes in here, it expands. And when it expands, its pressure changes and it becomes cool. That's one of the tricks, if you will, one of the mysteries of refrigerant. The refrigerant, if it's R22, what we call R22, boils. If you were to turn a tank of it upside down and let the fluid out of the tank, the R22 would hit the ground and immediately go to frost. It comes out of the tank and boils in atmospheric pressure at minus 41.4 degrees, 41.4 below freezing Fahrenheit. R410A boils at 61, 62 degrees below zero Fahrenheit. So this is a chemical. If we keep it under pressure, like anything, we can raise its temperature. If we reduce the pressure, we're going to reduce the temperature. So when you take the pressure off here, when you go from a small pipe under high pressure to larger pipes with a lower pressure, you're going to make a cold coil. So this is called the cold coil, this is called the hot coil. Now, what we're going to blow over here is, this is also called a line set, because this is the suction line, they call it, because the compressor sucks the gases back off of this coil, the cold gases. Now we're going to take a fan of some sort and blow air over this coil, because this is a cold coil, and we're going to take that air, put it in a duct system, and send it off to the house. Now the air that's coming over this cold coil is room temperature air. So if you've been to the beach all day, you get home, the house is 90 degrees, and you start your air conditioning system up, this compressor comes on, starts compressing gases,